I am Professor Nandini, Hindustan College of Engineering and Technology, Coimbatore, Department of EEE. We are going to see the topic Applications of Norton's Theorem. Then content of your topic is Introduction, what is Norton's Theorem, why we want to use this theorem, and real-time applications of this theorem. Example, limitations, advantages and conclusions of this theorem. Introduction. This Norton's theorem is a powerful tool in electrical engineering that simplifies all the complex linear circuits. Norton's theorem. The statement of this theorem is any two-terminal linear circuit can be replaced by an equivalent circuit consisting of a single current source in parallel with a single resistor. The current source, a single current source, is going to be an short circuit current IN and is parallel with a single resistor Rn. That Rn is going to be a looking back resistance or equivalent resistance. Why we want to use this theorem is, we have to use this theorem in order to make our complex circuits into very simpler equivalent circuits. By using this theorem, we can save our time and our more calculations too. Then this is also useful in evaluating how the circuits behaves with the different load conditions. And by using this theorem, we can design, simulate and even troubleshoot it more easier and in a more efficient manner. Applications of this theorem is, this theorem is used in your power distribution sites and is also used in communication systems and embedded systems and charging the circuits. We are using this theorem. This theorem can be explained with a simple circuit over here. Here is a circuit through which we have to find what is the current in the load resistor RL. Here the load resistor is going to be a 5 ohm resistor. First step in solving this problem is, we have to remove the load resistance and we have to short circuit the terminals by using the terminals A and B. We have to find, so the circuit has been redrawn as like this. Next, we have to find what is the current IN flowing through this terminals A and B. For this, we have to find what is the total resistance, and then we have to find what is the current over the total current. And by applying a current division rule, we can state what is the current through the terminals A and B. That current is said to be a short circuit current or IN current, Norton's current. In this case, we are getting a current as short circuit current as 1 amps. After that, we have to find what is the total resistance of the circuit. For that, the first step, we have to remove the sources and short circuit the sources. If it is a voltage source, we have to short circuit it. If it is a current source, we have to open circuit the terminals. So we have to find what is the total resistance. In this case, in this problem, we can find it as the total resistance is 15 ohms. Then we have to replace that simple circuit, an equivalent circuit for the circuit, by adding your circuit and your current and total resistance in parallel. Your current 1 amps and your 15 ohms resistors are in parallel. For that, we have to add your load resistance also. Here the load resistance is 5 ohms. So we have to find what is the current through this load resistance 5 ohms. For that, the same current division rule is applicable. So in this case, your IL is going to be 0.75. So limitations of this law is, this Norton theorem cannot be applied for a magnetic coupling circuits loads. If the load is in, the second point is, the load is in series or in parallel combination with the different sources, then this theorem is not applicable. Advantages, this theorem can be used to make our complex circuits very simple, and this reduces the circuit sizes also, and efficient load analysis can be possible with this theorem. This is nothing but it's a dual of your Thevenin's theorem. Conclusion, the Norton's theorem is very important in both theory and practical ways. It is mostly applicable in power systems, communications, embedded systems and charging circuits, and also for testing. If you are going to master this theorem, we can improve our design and analytical skills too. Thank you.